One point about the VLT is that from its site in Chile, you have access to the southern sky, and some of the most interesting objects are in the far south, so from England they are inaccessible. Well, Chris has been there, and he's had time to look round the wonders of the far southern sky.
It's nearly nightfall, and the sun's setting over the desert behind me as the professional astronomers up at the VLT are settling down in front of their computers for a night's observing. But what really excites me on this trip is the chance to see the sky for the first time from south of the equator at this superb site. We're looking forward to sights such as Orion seen overhead, beautiful views of Saturn, and deep sky objects like Omega Centauri, and the large Magellanic Cloud that we never get to see from the UK. It's going to be a stunning night. And with me are some of the world's leading astrophotographers. Damian from the UK is responsible for some of the most stunning images of the planets I've ever seen. And for local knowledge, with me is Belgian astronomer Daniel Verschatse, who's lived in Chile for more than 5 years. We've chosen a site just 100 metres below the VLT, and coincidentally, it's the site for ESO's newest telescope, VISTA. When completed, it will be the largest telescope anywhere in the world dedicated to large-scale surveys of the night sky, in this case, both in the optical and the near-infrared regions of the spectrum. We're trying to do as much of the setting up as possible during daylight hours, because here, literally within sight of the VLT, restrictions on light are incredibly tight. In fact, it's rare for anyone to be allowed to bring telescopes up here, so it's a real privilege for us this evening. Daniel, of course, has driven up from the south of the country, but Damian's managed to pack a surprising amount of kit into his airline luggage. So Damian, you brought your telescope out from England despite the excess baggage, but you've had to make some adjustments to it.
That's right, Chris. The polar axis actually needs adjusting because we're much closer to the equator here at Paranal. Where at the poles of the Earth, the polar axis of the telescope would be pointing directly at the zenith, and it will actually track the sky around in a circle. As you move further towards the equator, the lower the axis points, until eventually when you reach the equator, the axis would actually be horizontal. And here at Paranal, the latitude is about 24 degrees, which is about 25 degrees different from back in England.
And I know you're planning to look through it, but you're also planning to do some imaging today. So tell us about the camera you've got to do that.
I've actually brought along 2 webcams for imaging of the planets, a black and white webcam and a colour webcam. Of course, the webcams remain the most powerful tools for high-resolution imaging of the planets, and what better place to exploit it?
So I know you're looking forward, as I am, to the southern sky, but what are you going to look at first?
Well, of course, I'm completely spoilt for choice here in the southern hemisphere. I think my first object will probably be the Magellanic Clouds, as I've never seen them before.
Well, you'll have to fight me for the eyepiece, but thanks for bringing it all out.
Of course.
While Damian's imaging will focus on the planets, Daniel has other targets in mind.
We're looking at an object in Orion. It's commonly called the waterfall. It's a very small, dim star-forming region, and it's close to a nebula that's better known, which is called NGC 1999. It's just south of the Orion Nebula, which means up here. It's above the Orion Nebula.
So these are all part of the same star-forming complex in reality?
Yes, exactly.
And you create colour pictures in an interesting way?
Correct. We will take a sequence of probably 5 to 6 pictures in each color. That's red, green and blue. And then probably 8 to 10 pictures in luminance. That's the white light.
And then add them together in the computer?
And then in the computer everything gets mixed up together with a little bit salt and pepper, and we get a nice picture. Yeah.
Fabulous. Now, you've travelled all over Chile. You've lived here. And how does this observing site compare?
We'll be able to tell tomorrow, but from the looks of it, it looks fantastic. Yeah, we are very close to the ocean. It looks like the seeing is going to be marvelous. The wind is dying down. So everything looks like it's going to be real fun tonight.
And of course, the other advantage for us of having you here is we need a local guide to the sky. I've never seen the Southern Cross, let alone the faint fuzzies, as of now. So maybe you should tell us about a few of the objects in the southern sky that we won't know about.
Sure. I mean, well, I'm Belgian myself, so I needed some time to find my way around the skies, and sometimes I'm still looking a little bit upside down to find my way. But yes, the main highlights, of course, are the Magellanic clouds. They are deep in the south. Then we will have some other nice goodies like the 47 Tuc, which is a very nice globular cluster. We will see Omega Centauri, although it's a little bit low in the sky at this time of the year. And if we start early, we will have still a nice view of the Milky Way heading towards the west.
The Magellanic Clouds are our galaxy's most obvious neighbours. Two small dwarf galaxies, they orbit the centre of our own Milky Way, and each time they pass through, gas and dust is being stripped from them. In fact, our galaxy is actually cannibalising them. It's 3 hours after sunset, and with the moon above the horizon, it's still one of the clearest and darkest views of the sky I've ever had. And we're using a night vision lens to try and give you a flavour of what we can see from this remarkable sight. Daniel and Damian are still hard at work setting up their telescopes and cameras, but let's interrupt to get a tour of the southern sky. So let's start with the familiar parts of the sky, but there's something very odd about Taurus.
Yes, absolutely. We're seeing it completely upside down from how we usually see it in England, and the whole perspective of the sky is completely changed and very difficult to get used to.
Yeah.
The very distinct Pleiades cluster is really quite stunning to see.
And there's at least 12, 13 stars visible with the naked eye in the cluster. So again, it's a really good indication of quite how good a sight this is.
Absolutely. And of course we have Orion pointing at a very odd angle toward the horizon.
Yeah, the sword's hanging upwards from
Yes.
about with the nebula, which you can see is the second star, is obvious with the naked eye. It's obvious there's something going on.
Yeah.
You can see the nebula.
And Sirius is also in the Canis Major there, is upside down.
Yeah, it's interesting. Sirius, the brightest star in the sky, always seems to really stand out at home through the murk and the fog. But here it's bright, but it's not noticeably bright in some of the other.
Then if we go more south, we go in the direction of the Magellanic clouds, which
Right.
of course are not visible from Europe.
I can't believe how large on the sky they are.
Yeah.
They are absolutely remarkable to see for the first time.
But they're obvious with the naked eye. How do they look in binoculars and in a telescope?
Well, binoculars are fantastic for looking at these objects, and of course one object that I can't help but mention is the spectacular globular cluster 47 Tucanae, which we've enjoyed absolutely stunning views of this evening.
It's also my favorite one. The interesting thing about the Magellanic clouds is that each one has a highlight. Close to the smaller one is 47 Tucana, just mentioned. And on the edge of the other one, of the large Magellanic cloud, is the Tarantula Nebula, which is also a highlight in a Dobsonian or plain binoculars.
It's also where the nearest supernova to be detected in recent times went off in 1987. Was in that region.
Further down to the South Pole over there, Octans.
It's remarkable with the pole quite how empty a region of sky that is. There's no bright stars there at all.
That's correct.
Yes, polar aligning is... we are so lucky to have Polaris in the UK. We really are.
We've also got the nearest large galaxy in the sky. On the other side, moving back round towards the north, there's Andromeda.
Yes, it's completely, again, a different perspective than we see it from in England, but the incredible dark skies here at Paranal make it such an easy object to see even with the naked eye.
I've always said that you can tell how good a sight is by counting the number of stars you can see inside the square of Pegasus, and I lost count at around 30, which I suppose answers the question. How are things going?
Fine, actually. The wind is bothering a little bit, but the seeing is good and the transparency is good.
And we just got the first image of the field.
We just got the first image of the field. I'm brightening it right here now, so we see the nebula coming through.
You can see the waterfall quite clearly.
The waterfall is coming out. We can do a quick first calibration on it.
Right.
Just... Yeah.
Oh, and you've lost all the... Wow, that's an amazing image already.
Yes. But it's only one single frame, and it's still very noisy.
Of course.
What we have to do now is collect more frames
In different filters.
in different filters, and of the same filter as well. And then we will stack those different frames and get rid of the noise.
And end up with our full colour image.
Exactly.
I have to say, I can't believe the detail on that. There's so much nebulosity.
Going on, right?
Absolutely.
This area here is NGC 1999, the waterfall, and this one is a nice Herbig Harrow object in red. Yeah.
That's amazing. How long was this exposure?
This was 15 minutes, and so
Wow.
we're going to use about 20 shots.
Okay, well we should let you get on with it.
Okay.
Good. If I look at the small Magellanic Cloud through binoculars, it's an amazing sight, but there's a smaller patch of nebulosity just next to it. It seems very concentrated. Can't quite make out any structure in it. You got it in the telescope?
I certainly have, Chris. And this object is the globular star cluster 47 Tucanae, and the view is absolutely magnificent.
Yes, of course the binoculars show it, but they don't show any of the individual stars. What about the telescope?
Here in the telescope, you can
Let's
actually
have a look.
you can actually see the cluster resolved into many thousands
Wow.
of individual stars.
That looks almost as if you put a photo of it on the end of the telescope. That's absolutely incredible. You could still see the very strong central cluster.
Yes, it's very concentrated towards the core.
I mean, tens of thousands of stars in this object. It's almost a mini galaxy, but because it's close enough, you can actually see the stars. And then there seem to be some lanes. If you have a look in the outer regions, where you can resolve the stars, they seem to be almost concentrated into lanes.
Absolutely, Chris. I can also see these, and they radiate out from the core of the cluster.
Yeah, it's not something I'd seen. We have a couple of bright globulars in the northern hemisphere that we can see from the UK, but nothing like the resolution of this, nothing like the size of this one. It's incredible.
It's an absolutely amazing object compared to the M13, the best globular cluster we can see from England. It really, 47 Tucanae, shines above it.
Yeah, and of course it's ideal for small telescopes because you need the field of view. A bigger telescope would magnify in and you'd miss the splendour of the whole thing. It's just incredible.
Absolutely amazing.
It's 2 a.m. and with the Southern Cross and Eta Carina rising behind me, I'm going to call it the end of a fabulous night's observing up here on the mountain and leave Daniel and Damian to get on with their hard work. I can't wait to see the results in the morning. We should have some truly stunning photographs of this beautiful sky.
Certainly, Chris was enjoying the southern sky, and most rather I wasn't there too. So now, on to the great new telescopes. Welcome back to Isabel. I'm delighted now to welcome also Dr. John Richter, the radio astronomer. We know about large telescopes, and one and more are being planned. And one of these is the OWL, overwhelmingly large telescope. And that really is going to be large, Isabel, isn't it?
It is. It's going to be very large. The proposal from the European Southern Observatory, ESO, is to build a telescope 100 metres in diameter, which is over 10 times the size of the current telescopes we have when measured in the diameter of the telescope.
It's in the planning stage now?
It is in the planning stage, and it's one of many that are being considered for future telescopes.
I remember a conversation I had many years ago with, of all people, Edwin Hubble, talking about the building of the 100-inch reflector on Mount Wilson in 1917. And Hubble said to me then the purely engineering problems were just as great as the optical problems. And with OWL, the purely engineering problems must be horrendous.
It will be a challenge, definitely. This structure will be similar in size to for example, the Jodrell Bank radio telescope, but made of glass and steel, and the whole structure, which could weigh up to 14,000 tons, has to be tipped around the sky in the same way we do with current telescopes. So it's certainly a challenge.
Of course, it's not a single mirror, is it?
No, it's not. The largest single mirrors that we can build at the moment are about 8 metres in diameter. So obviously to build a telescope up to 100 metres in size, we have to build it up from many smaller segments.
How
and
many?
then, well, there'll be over 3,000 in OWL for a 100-metre telescope.
One thing we've got to remember, I think, is that all branches of astronomy now work together. Optical astronomy and, of course, radio astronomy. And, John, great developments here. What about ALMA?
Well, indeed, Patrick, ALMA is a radio telescope which we're currently started constructing in Chile. And this telescope is being designed to answer some of the fundamental questions about origins of planets, of stars, and of galaxies in the universe. This is currently one of the very exciting topics in astrophysics. Now the problem is that these objects all form in very cold gas clouds. And if we want to look at these gas clouds, then we have to work at wavelengths which are 1,000 times longer than optical light. In other words, a wavelength of about 1 millimetre. So the Atacama Large Millimetre Array, ALMA, is a radio telescope which is designed to detect radiation with a wavelength of about 1 millimetre and make very detailed images of these gas clouds where stars, planets and galaxies form.
How many dishes involved?
Well, we are building 64 separate dishes. Each of those is a 12-metre parabolic reflector. And in total that makes a collecting area very similar to a 100-metre single telescope. But we move the telescopes around this very high plain in northern Chile, and by spreading them out over a very large plain, we can synthesize the effect of a single dish up to 15 kilometers in diameter.
How can OWL come in this one?
Well, OWL is also an extremely powerful tool for spectroscopy because of its extremely large collecting area, and it allows you to take spectroscopy of very faint sources, for example planets orbiting around other stars. And that may allow us to look for the first signs of biospheres or atmospheres around these planets and possibly the first signs of life.
Everything is coming together, isn't it?
Very much so, I think, yes. Increasingly you can't use a single telescope to answer your astrophysical problem. You need to build a suite of complementary instruments and use them all to answer the scientific question you are chasing.
Isabel, John, thank you very much. So I wonder, where are we going to go? For one thing I'm quite sure, there are many surprises in store, and personally I always expect the unexpected. Meanwhile, when I come back next month, we're going to talk about the Saturn probe and the exploration of Saturn's big satellite, Titan. Until then, good night.
There's an extended version of The Sky at Night when Patrick learns more about the world's largest telescope tomorrow at 8:30 over on BBC 4.